Last Tuesday, we visited the laboratory to conduct an experiment aimed at determining the concentration of calcium in fulcrum milk using AAS, which is atomic absorption spectroscopy. Junyuan, as our leader, assigned specific tasks to me and Li Hui. Firstly, I calculated our V1 to determine how much ppm of calcium standard solution we needed to add into the volumetric flask. Using the formula M1V1 equals to M2V2, we calculated the volume needed for different concentration of the stock solution we set ourselves, which is 5 ppm, 10, 15, and 20 ppm. Next, we used a micropipette to take 2.5 ml of fulcrum milk and added it to the volumetric flask, labeled as 10-fold. After that, we added buffer inside. We then took out 2.5 ml from the 10-fold volumetric flask and added it to the 100-fold volumetric flask, continuing this process for subsequent dilutions such as 1,000-fold, 10,000-fold, and so on. Let's watch a video that shows how we walk and perform the experiment together.
If you're talking, I want to listen, I want to know. Baby, love you, that my reason is to let you go. Now do you think of you only and you? Please don't tell me that you're such a mess. I'm gonna promise we'll leave you okay. You be something, you be something, please don't tell me that you're such 'cause you don't say. Tell me somebody else.
After a dilution were made, we were the first group to use the AAS to determine the concentration of calcium in milk. Ms. Neal taught us how to use the machine, and each of us gained individual experience in operating it. While the machine was running, we observed changes in the color of the flame and light. Let's watch a video. Once the experiment concluded, we utilized the standard means absorbance and the concentration of the calcium standard solution to plot the graph. This graph provided us with a reference to determine the concentration of calcium in the sample, which is a fulcrum milk, using the sample mean absorbance. After determining the concentration of calcium in the sample, we then scaled back the dilution factor of 100, 1000, and 10,000 folds. This process enables us to obtain the exact concentration of calcium in the fulcrum milk sample, taking into account the dilution factors applied during the experiment. Setting goals for future progress. During the last lab session, I wasn't adequately prepared for the experiment because I failed to review the lab manual beforehand. Consequently, I lack of understanding of the procedures and tasks for the day. To avoid this in the future, I commit to truly reading the lab manual before each session. The most confusing and unclear aspect of this practical was not understanding the meaning of tenfolds at the start of the experiment. I later realized that tenfolds refer to diluting the sample by a factor of 10. Another aspect that confused me was using 25 ppm as V2 to calculate the V1. In our case, we are diluting from a non-concentration of 25 ppm to a final volume, let's say 25 ml, assuming that is the volume of our flask. And one surprising aspect of the experiment might have been the process of plotting graph using the standard mean absorbance and interpreting it to determine the concentration of calcium in the sample might have been surprisingly insightful. Discovering how the graph provided a clear reference for calculating the sample's calcium concentration and understanding the significance of each data point could have been an unexpected aspect of the experiment. Another surprising point could have been the learning experience again from using the AS machine for the first time. Despite initial apprehension, being able to operate the machine effectively with guidance from Dr. Neal and observing the changes in the flame and light during the analysis. That's all from me. Thank you.